Hello students, I welcome you all to my channel Engineers Academy. Do subscribe my channel if you haven't done it yet. Now we are going to solve this problem from chapter 12, Hibbeler dynamics. The problem says that at the instant shown, cars A and B are traveling at speeds of 55 mile per hour and 40 mile per hour respectively. If B is increasing its speed by 1200 mile per hour while A maintains a constant speed, determine the velocity and acceleration of B with respect to A. Car B moves along a curve having radius of curvature equals to 0.5 mile. So we are given the velocity of car A, which is 55 mile per hour, and the velocity of B, which is 40 mile per hour. So we have to find VBA, and we have to find the acceleration of car B with respect to A. So first of all, we will find the velocity. So for velocity, we have to find the Cartesian vector representation of VA and VB. So now as we can see that this VB is making 30 degree with the horizontal. So we can resolve this VB into its components. So this is VB, which has a magnitude of 40 mile per hour, and it is making 30 degree with the horizontal. So it will have two components. One of its components is going to act in this direction, and one of its components is going to act in the upward direction. So this one will be 40 cos of 30, and this will be 40 sine of 30. So if we draw the absolute coordinate system, this is the x and y direction, and the translating coordinate system is attached with car A, since we are measuring the velocity of B with respect to A. So this cos component of this VB is acting in the negative x. This is our positive x, so it is acting in the negative x. So we can write that VB vector is equal to 40 cos of 30, and it is acting in the negative I, and then we have plus, this is in the negative I, and then 40 sine of 30, this is in the positive j. So 40 cos of 30, this is minus 34.641 in the I, and then 40 sine of 30, this is plus 20 j. So this is the Cartesian vector representation of that VB, the velocity of car B. And similarly, the velocity of car A is only directed in the negative x direction, so we will write that VA is equal to minus 55 mile per hour, that is in the negative I, and its j component is 0, so we will write that this is 0j. And now we know that VBA vector, this is always equal to VB minus VA. Now VB is minus 34.641 I plus 20j, this is VB, minus VA is minus 55 I plus 0j, and we can write that this is minus 34.641 I plus 20j, and this minus into minus, this will become plus. So plus 55 I and minus 0j. So now we will add the I component with I. So this will be minus 34.641 plus 55 I, this is plus 20 minus 0, this is j. So this will be the Cartesian vector representation of the velocity of car B with respect to A. So minus 34.641 plus 55, this gives us 20.359 plus 20j. So this is VBA. So now we can say that both of the components of VBA are positive. This is the x component of VBA and this is the y component of VBA. So now we can draw that, right? So the relative velocity of B with respect to A is acting in this direction. This is VBA and its x component is positive. This is its x component. This is equal to this VBAX. This is equal to 20.359, and the units of this is in mile per hour. So this is in mile per hour, and similarly it will have one component like this, and that will be VBAY, and its magnitude is 20. So we will write that this is 20 mile per hour. Now if you want to find the angle of this VBA with the horizontal, let's say this angle is theta, so then this angle theta will be equal to tan theta. Tan theta equals to the perpendicular divided by base. So the perpendicular is VBAY, which is 20, and the base is VBAX, which is 20.359. If we take tan inverse, we will be able to find that theta. So tan inverse, so that is 20 divided by 20.359. This gives us 44.49 degrees. So this is theta equals to 44.49 degrees. So VBA vector, this is VBA vector, it is making 44.49 degrees with the horizontal. And if you want to find the magnitude of VBA, so the magnitude of VBA will be equal to, by using the Pythagoras theorem, we can write that this is 20.359 square plus 20 square under the square root. So this will give us 20.359 square plus 20 square. So this is equal to 28.539 mile per hour. So this is VBA magnitude. So car B is moving relatively to car A with a velocity of 28.539 in the direction, in such a direction when it is making 44.49 degrees with the horizontal. So this VBA magnitude is 28.539 mile per hour. Now we have to find the acceleration. So for acceleration, let me copy this. Now as we can see that it is given that the acceleration of car B, the acceleration of B is increasing speed with 1200 mile per hour square. So this is the acceleration of B, and it is said that while A maintains a constant speed, so the acceleration of A is 0. So let me write that the acceleration of car A is 0 I plus 0j. And now as we can see that this 1200 mile per hour square is the tangential acceleration of this car B. So the tangential acceleration is always acting in the direction of the velocity, that is, the velocity is always tangent to the curve. Since this car B is moving in a circular path, so this VB is tangent to the curve, so the acceleration will always be in the direction of this VB. So this means that the tangential component of the acceleration of this car B is acting in this direction, which is making 30 degree with the horizontal. So now we can show that, let's say if this is the horizontal line and this is the tangential acceleration, this is the tangential acceleration of B. Let me write this as, so this is AB in the tangential direction, and this is equal to 1200 mile per hour square, and this is making 30 degrees. Now we can resolve this tangential acceleration into its components. So it will have one component like this, and it will have one component in this direction. This one will be the cos component, so we can write this is 1200 cos of 30, and this component is 1200 sine of 30. And similarly, since car B is moving in the circular path, so it will have the normal component, and its normal component will always act perpendicular to the tangent of the path, right? Since this car B is moving in the circular path. So if it is moving in the circular path, so this means that if I draw again that horizontal line, and if this is that line which is tangent to the curve, so the normal component of the acceleration will always act perpendicular to this tangent line. So this will be AB normal. This is, I can write that this is AB normal acceleration. And if I draw a vertical line, let's say if I draw a vertical line like this, so since this ABN is perpendicular with this line, and this line is perpendicular with this, and the angle between these two is 30, so the angle between the acceleration of B in the normal with the vertical is that angle is 30, right? So we can write that this angle is 30 as well. Now we can resolve this normal acceleration into its components. So again, it will have two components. One of its component is going to act in this direction. This one will be the cos component, and this one will be the sine component. So we can write that this is A B n sine of 30, and this component is A B n cos of 30. So now we have to represent the tangential acceleration as a Cartesian vector and the normal acceleration as a Cartesian vector. So now I can write that the acceleration of B in the tangent, that vector, this is equal to this 1200 cos of 30, this 1200 cos of 30, and it is acting in the negative x. This is our positive x. So I will write minus 1200 cos of 30 in the I, and then this 1200 sine of 30 in the positive j. So I will write plus 1200 sine of 30 in the positive j. So now this is AB tangential, and minus 1200 cos of 30, this gives us 1039.230 in the I, and then 1200 sine of 30, this is 600. So this is the Cartesian vector representation of the acceleration of B in the tangential direction. So these are the components of AB tangential along x and along y. And similarly, first of all, we have to find the AB in the normal direction, its magnitude, the acceleration of B in the normal direction. So the acceleration of B in the normal direction, magnitude, this is always equal to VB square divided by the radius of curvature. And we know VB, which is 40, so 40, this is 40 square, and the radius of curvature is given in the statement. This is 0.5, so we have to divide this by 0.5. So 40 square divided by 0.5, this gives us 3200. So ABN, the normal component of the acceleration of B, is equal to 3200 mile per hour square, and remember that this is in mile. So now from this we can write that this is the sine component is acting in the positive direction. So I can write that the Cartesian vector representation of the acceleration of B in the normal direction, this is equal to ABN sine of 30, and ABN magnitude is now known, which is 3200. So 3200 sine of 30, this component is acting in the positive I, this is acting in the positive I, and this is acting in the positive j. So I will write plus ABN, again ABN is 3200 cos of 30 in the positive j. So this is 3200 sine of 30, 3200 sine of 30, this gives us 1600, and then 3200 cos of 30, this gives us plus 2771.281 in the j. So now we have to find the acceleration of B. So acceleration of B is equal to the ABN plus ABT. So now we have to add ABN and ABT. So we have to add the I component of ABT with the I component of ABN. So we can write that the ABT I component is this. We can write that this is 1039.230 plus this 1600. And remember that this is negative, this is minus, so we have to write that this is minus 1039. So I have to write minus here and plus 1600. This is plus, so this is in the I, and then we have to add up the Y component. So this is 600 and this is 2771.281. So I will write plus 600 plus 2771.281 in the J. So now if we add this is minus 1039.230 plus 1600. So this is plus 560.77 I, and then plus 600 plus 2771.281. This gives us 3371.281 in the J. So this is the Cartesian vector representation of the acceleration of car B, and the acceleration of car A is 0. So now we can write that the acceleration of car B relative to car A is equal to AB vector minus the acceleration of A. So that will be equal to this vector minus that 0. So we will get that AB, right? So we can write that this is 560.77 I plus 3371.281 J minus 0I plus 0J. So we will get that same vector. So we will get that same AB vector. So this means that the relative velocity of B with respect to A is equal to the acceleration of B. So now we have to find the magnitude of the acceleration of B with respect to A. So the acceleration of B with respect to A magnitude is equal to, by applying the Pythagoras theorem, so this is 560.77 square plus 3371 square, and then we have to take the square root. This is 560.77 square plus 3371 square. So this gives us 3417.324 mile per hour square. This is the magnitude of acceleration of B with respect to A, and we can find the direction of this ABA, since the x component of ABA is acting in the positive x and the y component is acting in the positive j. So we can write Cartesian vector. We can represent it as graphically. So ABAX is acting in this direction. This is ABAX and this is ABAY. So this will be AB vector, or we can say that this is ABA. So this is that angle theta with the horizontal, so we can apply tan theta. So by tan theta we can write that tan theta is equal to the acceleration of B with respect to A, the y component, divided by the x component. Now the y component is this is 3371.281 divided by the x component, which is 560.77, and if we take tan inverse we will be able to find the angle of the acceleration of B with respect to A with the horizontal. So this is tan inverse, and that is 3371.281 divided by 560.77. So this gives us theta equals to 80.556 degrees, or we can say that this is 80.56 degrees with the horizontal. So this is, we have this angle, and the magnitude of the acceleration of B with respect to A is this 3417.324, and the velocity the relative velocity of B with respect to A is magnitude is 28.539 and it is making 44.49 degrees with the horizontal. So this is the solution of this particular problem. I hope this will help you in your learning.